Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. You have to decide for yourself which test to use. So press pause and have a go. Okay, so the first test we should use is the nth term test, meaning we should look at the limit as n tends to infinity of an. So what is the limit as n tends to infinity? Well, if you look at the denominator is going to get very, 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 very big as n moves from 0 to infinity. The numerator, well, the cos graph looks like this. It's going to oscillate between 1 and -1. And when you square it, it will no longer be negative, but the highest value is going to be 1. So this is the highest value this thing here could be is 1. And then you've got 1 divided by something very, very, very big. It's going to head towards 0. So because the limit of this thing here, because the limit of this thing here heads towards 0, you can't determine anything. If it heads towards some other number other than 0, then you can determine that it's going to diverge. But because it's heading towards 1, we can't determine anything. We have to use some other tests. Well, as it turns out, we should use the comparison test. So when you look at this here, remember the comparison test is that this thing here is our an here. If you can compare an with something that's always bigger or equal to an, then if this thing here, if this thing here converge, well, by the way, if you look at this, we should compare it to we should compare this to 1 over 5 to the power of n, because the highest, if you look at this, the cos graph looks like this, and when you so this is going to be 1, and this is going to be -1. This is just going to oscillate. Cos of n will just oscillate between 1 and -1, and when you square it, it will always be positive. But the highest value that this thing here could be, the highest value that this thing here could be, would be 1. And you see, you should compare this with 1 over 5 to the power of n. Well, so this here is our 1 over 5 to the power of n, and then this is what we're trying to investigate, an. Well, if this thing here converge, then the series that we're trying to investigate, which is this one here, an, will also converge. In this case, we don't need this. But if this thing here diverge, then this being always bigger than this, if this thing here diverge, then this will also diverge. And we've seen this before. You should know this by now. So in short, you should compare this with this. So the thing that we're trying to investigate is always less than or equal to this thing, and always greater than 0. Because if you look at this, when you square this, it will always be positive. This thing here will always be positive, so it will always be bigger than 0. Don't forget, to use this comparison test, we need to make sure that it's non-negative. Well, it's bigger than 0, so it's always non-negative. Okay, so compare it. So we are trying to investigate this. We are trying to investigate this, but then we are going to compare it to this. So as it turns out, rewrite this as this. This here you should recognize. You've got to recognize that this is a geometric series. So when it comes to a geometric series, you know, when it comes to a geometric series, you should automatically know that this thing here is going to converge. And then, well, if this thing here converge, then this thing here will also converge. That's what the comparison theorem is saying. If this thing here, if the summation of this thing here converge, then this must also converge. So if you look at this, the thing that we're trying to investigate is always less than or equal to this. Well, this thing here converge because it's a geometric series. Therefore, this will also converge. Okay, so our conclusion is that this thing here will converge. If you want to take it further, because it's a geometric series, we can always compute. We had a formula for working out the summation of a geometric series. So as it turns out, by using the formula, it gave us this. So what that means is that this thing here is what we're trying to investigate. We know that this thing is always less than or equal to this thing here. Well, we've got a formula that allows us to work out the whole summation of the geometric series, which turns out to be this. By the way, that formula is this thing here. Okay. Well, you should already know this. So this thing here will then give us this. Well, you can actually conclude that what you're trying to investigate is going to be bigger than 0 or equal to 0 and less than or equal to this thing here. So the whole series here is trapped somewhere in between here and here. We don't know what it is precisely, but we know it's going to be in between 0 and 5/4. Okay.